All right, so let me kind of tell you what's going on this week. So I put the grades in the grade book. I loaded your homework from 7.1 through 7.5 in your first quiz. If you did not finish your homework, you can still do it for 70%, you know, so get her done. You should be able to get your stuff done. Sorry, let me close this. You guys can see my screen, yes? Online? Okay, all right. So this week, we're going to cover 3 sections, all right? We're going to cover 8.5, 2.3, and 2.4, all right? Today in class, we're going to cover 8.5. 2.3, I've already put the video up there. It's online for you to watch. And 2.4, all right, we'll do on Thursday. So you're going to have homework. You have quiz 2 that's due at midnight. If you ever wonder what to do, you can always go to eCampus. If you go to the course homepage, let's find you guys. Week 2, okay, right there on the homepage, I say this is what to do. We're going to be covering 8.5, 2.3, and 2.4. These homework assignments in quiz 2 are due Sunday at midnight. 2.3 is completely online. Watch the video, post to the discussion forum about it for attendance credit. 7.3, we didn't finish that last time. I put a video up there on that. All right, so you can watch that if you need to. I posted some help with Venn diagrams. Some people were struggling with Venn diagrams in 1324, so I put a video up there, okay? And you're free to watch that. Now, in terms of what to do, go to content. If you look on test 1 material, it has 7, we did this last week, 8.5 is where it starts. And then we run out. So if you go to exam 2, it's not really that there's an exam, it's just called exam 2 material. 1.2, you'll notice we're not doing that yet. We're doing 2.3 and 2.4, all right? If you click on 2.3, and if you click up here, there's the links to the videos that I've already put up there because that's asynchronous. And also on the bottom of 2.3, there's a discussion, all right? Please post your full name, certify you've watched the video, make up an inequality problem and answer the previous person's inequality by writing an interval notation, that's after that video. To find the infinity, I'll show you how to find those, but I'll get us started. My name is Donna Miller. I watched the lecture video on 2.3. The inequality x is greater than or equal to can be written as, and I wrote an interval notation. If you watch that video, you know what that means. And so the next person to write the interval, next person should write the interval notation for x less than 3. So what I want you to do is, if I were the next person on my post, I would write less than 3. So I'd go like from negative infinity to 3. And then I'd make up a new problem, you know, let's say I'd say, and then write, you know, x is greater than or equal to -1. And then the next person can answer that, okay? You understand? So you look at the post above yours, see what problem they gave you and answer it, okay? All right, so that's the discussion forum. If you ever want to access your quiz, you always can access the quizzes through MATLAB. I do put links up there. I go back. Where the heck is it? Like 2.4 would be the last section. At the end of that section, I have a link to your quiz in MATLAB. All right, or you can also access it through MATLAB. All right, any questions about what we're doing this week? All right, you good? All right, so 3 sections. All right, so we're going to start with 8.5 today and my stuff, and then we're going to go to their stuff. Okay, so we talked about, last time we met, we talked about exponents, and exponent rules hold whether you're working with whole numbers, negative numbers, and fractions. So today we're going to talk about fractional, or what they call rational exponent. Rational means the same thing as a fraction. It has the word ratio in it, which means it's a fraction. All right. So we're gonna give you a little bit of background now. These rational exponents, you're going to be wanting to work with them in 1325. So some of the stuff in this class is 1325 related, some is 1324. It's easier to work with fractional exponents than square roots. So before I go into her notes, we kind of talk about. So the whole idea of this is that if I have the square root of something, you know, whatever it is, x, I can write it as a fraction. I can write it as x to the 1/2. All right. So if I wanted to do the square root of 4, I could also write it as 4 to the 1/2. All right. So what happens is a square root, you know, okay, square root of 4, I know it's 2 because 2 times 2 is 4, but you can also do cube roots. So if I do the cube root of 8, I'm saying what times itself, this index here, this is called the index. And since there's a 3 there, I'm saying what times itself 3 times is 8. So what number times itself 3 times is 8?
What was the question?
2.
Right, because 2 times 2 times 2, right, is 8, right? So the cube root of 8 would be 2. Okay? Cube root of 8 is 2. So I could have things like, you know, what's the fifth root of 32? I'm going, oh, well, what times itself 5 times is 32. All right, and it's going to work out to be 2. But my point is, there can be other things there besides just square roots. A square root the index is 2, but they don't write it. They don't write a 2 by the square root, right? That's just like kind of your basic square root, so they don't write 2 by it, but it's implied to be a 2. Everything else has an index. So this number up top is your index, okay? So when you get to upper math, you really, working with square roots is really kind of a pain in the neck. You really want to work with them in rational form. So we're going to talk about how to convert. It turns out that when you have x to a power, let me just start simple. If I have x to the 1/3, so that means the same thing as the cube root of x. All right. So it means the same thing. So if I have x to the 1/5, it means the 5th root of x. All right. So that number on the bottom of the fraction is what we call the index of the square root. Then they can do things like this: x to the 2/3. So what that means is that the number on the bottom is still the index, and you keep the power, you keep the 2 up top. So that the number on top is the power, the number on bottom is the index. Okay. So here's the rule. All right. Turns out that x to the m over n is the nth root of x to the m. All right. So for example, x to the 3/5 is the 5th root. You put the 5 on the outside and you put the 3 as the power. So it's the 5th root of x cubed. All right. Turns out it doesn't matter what you do first. So you can take the square root and then do the power. So I could also do the 5th root of x and then cube it, right? So I can do whatever works best for me, right? It doesn't matter what order you apply them, but the number on top is the power, the number on the bottom is the index of the square root. So let's talk about just with numbers for a minute. If I'm talking about 8 to the 2/3, right? With numbers, it's usually easier to do the bottom first, but we're going to do the top first. So I can write this as the cube root of 8 squared, right? And then 8 squared would be what?
What was the question? 8 squared.
So that's 64. Because 8 times 8 is 64. What times itself 3 times in 64? That's a harder one. Times itself 3 times in 64. And we'll talk about the calculator next.
4.
4. So the cube root of 64 is 4. Now that was a little harder because I had to figure out the cube root of a big number. Well, usually what you can do though with numbers is I can take the cube root of 8 first and then square it. And usually it's easier to go that way. What's the cube root of 8? So what number times itself 3 times is 8?
2. 2 times 2 is 4, 4 times 2 is 8.
2. All right, so it'd be the same thing as 2 squared, which guess what? It's also 4. So my point here, it doesn't matter what you do first, they're equivalent. Okay. Now on the calculator, let's talk about the calculator. All right. Do you know where the cube root button is on your calculator?
Mm-hmm.
Okay, so if you don't know, all right, math, there's a couple things you want to pay attention to. Number 4 there is the cube root. So if I pick number 4 and if I type, there it is, the cube root of 8, right? I guess so it's 2. If I wanted the 5th root of 32, then I'm going to go down to number 5. And it comes out like that. And you just have to type the index. So 5th root of 32, right? This 2. But I know what a fifth root is. I could also write 32 to the 1/5, and it does the same thing. So my calculator could also type 32, raise it to the 1/5. Right, and that does the same thing. All right. So you want to get comfortable with your calculators with root buttons. All right. So what's the bottom line here is the denominator of the denominator is the bottom. Is the index. It's the number outside. The bottom goes outside. The numerator is the power. All right, so the numerator is the power. All right, so we're gonna talk about that deal. All right, so x to the 1/2. So if I want to write that as a radical, by the way, a radical is this thing. That symbol, that's a radical. Okay, that's a radical. So they're asking you to put it in terms of roots. So x to the 1/2, basically that tells me I just got to take the square root of x, right? I'm raising it. The index is 2. When the index is 2, you don't write the 2. You just leave it out. It's x to the first power, all right? So if I want to write x to the 2/3, what I'm going to do is I'm going to put my square root symbol down. This number goes on the outside. 2 goes on the inside with the x. So it's the cube root of x squared. And again, it doesn't matter whether a cube root or square first. I could also write this as the cube root of x and then square it. It just doesn't look as pretty, but they're equivalent. All right. It doesn't matter whether I take the root and square or the square and take the root. All right. Here's what matters is number 3. You have to remember these are exponents. So exponent rules apply. Okay. The power, the 2/3, what's being taken to the 2/3?
X.
X, right? No 2, right? The 2 is not being taken to the 2/3. Remember, the exponent only applies what it's next to, right? So what you have to do with this to write it as a radical is leave the 2 outside because the 2 has nothing to do with the radical. Then you do your square root. We're going to put the 3 on the outside and the 2 on the inside. All right, see how the 2 was not involved in the power because there were no parentheses. See, that's totally different than something like this. Right? If I've got parentheses around it, the whole thing is being taken to the 2/3, so the whole thing goes under the radical. So this would be written as the cube root of 2x, the whole thing squared. See the difference? All right, and if I square that, it really is the cube root of 4x squared. I just squared both those guys. Okay, so there's a big difference whether there's parentheses or there's not.
Okay, so that one would be
Good question.
cube root to x 4. Right.
Good question. All right, so x to the 4/3. So you guys tell me what number goes on the outside of the square root?
3.
3. And then we put x to the
4.
4, right? All right, so like with number 2, that 3 is not being taken to the 7/2, only the x. So it's going to be 3 x to the 7th. We don't put the 2 on the outside because the 2, we just kind of leave it. It's a square root. All right. Is that all right? Yeah.
Did I get question 18? Yeah. David Vera.
Okay. So this next one, now look, the negative is not next to the x, right? So we don't put it on the, we put it on the outside. We're going to cube the x and we're taking the square root, so we don't put anything on the outside. All right. Is that okay?
X to
Yeah.
thirds.
To be honest with you, putting things in square root form is not really what we do. We put things from square root form into rational form. When you get to 1325, this is what you're going to want to do. All right, so we're going to do that. So basically, I just write this as a fraction. So rational means fractions. exponent form. So the number, the power goes on top and the index goes on the bottom, so it's x to the 2/3, but the power on top, the index on the bottom. All right, you good? All right, now this next one looks really gross, right? It's got x's in there. X squared I'm gonna leave alone. How do I write the square root of x as with a fraction? X to the what?
No idea.
1/2, right? 1/2. Now, I'm not done though, because now look what this looks like. I'm multiplying two things together to have the same base, right? So now I go down to my exponent rules, right? So when you multiply exponents, what do you do with the powers? All right, let's think, I want to try to tell you, if you had x squared times x cubed, what would it be?
X to the 5th.
So you add them, right? So same thing here, just because they're fractions, the rules don't change. You're just going to add them, right? So 2 plus 1/2 is 2.5. All right, so this is going to be x to the 2.5. I want to write it as a fraction, it'd be 5/2. Okay, so your exponent rules don't change just because you got fractions. They still apply. All right, you guys tell me how to write the next one. X to the what?
X to the 4/3.
Okay, she says
3/4.
x to 4/3.
3/4.
3/4, right? Because remember, this goes on the top, right? And this goes on the bottom. Okay? Power on top, index on bottom. All right. There's no power, it's to the first power, so the top would be 1 and the bottom would be 3, right? The 2 had nothing to do with it, so I left them outside. If you have an expression inside the radical, go ahead and put that expression in parentheses. So this would be -4 times, I'm going to put xy in parentheses. What power am I raising xy to?
1.
1/3, right? Good. 1 on top, 3 on the bottom. If you like, we have a rule, we can pull that, we can distribute that through. So it's -4x to the 1/3, y to the 1/3. All right, the 4th root of 81, we're going to write it as 81 to the what?
1/4.
4th, okay? And you can plug that in a calculator to get it, just to kind of mention it to you. You know, what times itself? 4 times is 81. One way to do this is just factor it down. I just do a little factor tree. So it's 3 times 3 times 3 times 3. So I know the 4th root of 81 is 3. All right, is that right? Okay, so that's my stuff for today. Now, so you got to remember the index goes on the bottom, the power goes on the top. All right, you get that thus far? All right, so we're going to go upstairs and we're going to look at section 8.5 with math 1324, which is probability distribution tables. All right, have you done those yet in her class?
Yeah.
So you have to add to 1. Yes? No, we don't know. Are you done? Yeah. Probability, okay. So you'll get into that. That'll be the next thing. All right. So I put a video up on the rest of 7.3 if you want to watch that on probability. I'm going to go up and we're going to cover 8.5 here, which is probability distribution tables. I should have just, no, I won't do it. There we go. That's fine. All right, let's talk about what is a probability distribution table. All right, they make these probability tables. Do you guys care if I take this off because you're 20 feet away from me? And, okay, because you did. Okay. It's just really hard for me to breathe. All right, so with these tables, what you want to do is you're going to list all the possible outcomes of an experiment and the probability of each. The most important thing about probability distribution tables is all the probabilities as you add them should add to 1 because it gives you all possible outcomes, okay? So usually on a test, they may like give you all but 1 and you have to fill it in. Well, you know it has to add to 1, so you do 1 minus a little bit. So we're gonna do an experiment. We're gonna come up with some probability distribution tables. All right, so you're rolling a weird dice. You're rolling a pyramid-shaped dice. It's got 3 faces, and it's got 4 faces. It's got a bottom and numbers 1, 2, 3 on the sides. And so you can only get numbers. You can only roll 1 through 4. All right, if you've ever seen some of these weird-shaped dice. And what we're doing here is we're using a dice table to lay out all possible rolls. So I'm going to roll a blue dice and a red dice. And my blue rolls, I get 1, 2, 3, or 4. My red rolls, I get 1, 2, 3, or 4. So if I lay out all the combinations, if I put the red one first, it's 1, 1, 1, 2, 1, 3. See how I'm doing that? So I can lay out all, these are all my possible combinations of rolls I've got. And this is called a dice table. Okay, it's just a 4-sided dice as opposed to a 6-sided dice. All right, so these are all the possible rolls. Okay. All right. This is section 8.5, and your notes is 21, page 21. All right, so here's what we're going to do. She does have one little error in here. I'm not going to call this how many, I'm going to call product, the product even or odd. All right, so what you're going to do is you're going to roll the dice, and you're going to see whether the product is even or odd. So the product is the multiplying. So if I multiply 1 times 1, that's 1, and so 1, 1 is odd. 1 times 2 is 2, so that product is even, right? So these are all the possible products. So when I roll the dice together, either the product is going to be even or the product is going to be odd, right? Those are my only 2 possibilities, right? You can't get anything else, right? It's either going to be even or odd. Now, there are 16 possible outcomes because there's 4 here and 4 here, so there's 16 possible rolls. Now, the probability that I roll an even product, so I'm going to go and in this table, I'm going to circle all the even products. So I go, okay, well, let's see, 1 times 1, that's 1, that's odd. 1 times 2, that's 2, so that's even, right? That's an even product. 1 times 3 is 3, no, 1 times 4, that's even, right? See, I'm circling all the even products. 2 times 1, even. 2 times 2, even, that's 4. 2 times 3 is 6. 2 times 4 is 8. All the 2's are even. Okay. 3 times 1, that's 3. 3 times 2 is 6. 3 times 3 is 9. That's no good. 3 times 4 is 12. All right. So those are even. And 4 times 1, 4. 4 times 2, 8. 12. All these 4's are going to be even. All right. So every one I circled, the product is even. Okay. So the probability that I get an even product, I'm going to count how many circles I got. You got 12 circles, right? So the probability that I roll an even product would be 12 out of 16. All right. And if I reduce that, it'd be 3 out of 4. Everybody good with that? So the probability that I roll an odd product, I'll just put those in yellow. So the odds would be the ones that are left over. This one, this one, this one, this one. So the probability I roll an odd number would be 4 out of 16. If I reduce this, it's 1/4, okay? So that's the probability distribution table. I want you to notice 3/4 plus 1/4, that adds to 1. It must always add to 1, all right? Clear on that? Has to add to 1, all the probabilities, okay? So these add to 1 because they're all the possible things that can happen. All right, we good? Any questions? All right, so we're going to do another experiment here. Now we're going to roll the 4-sided dice and observe whether both numbers are odd, both are even, or if there's one of each. All right, so I'm counting how many evens. This is what they're asking me. So I can either get 0 even, 1 even, or 2 even, right? Yeah, if they're both odd, you get 0. Got to put it up here, both odd. only one even, and this is both even. Okay, so I'm gonna go count the number of ways I can do that. All right, so I'm gonna go up to my dice table. I'm gonna clear up all my circling here. I'm taking count of how many evens. All right, both, how many of both odd numbers? So I'm gonna circle those, both odd. So 1, 1, they're both odd. 1, 2, 1, 3, they're both odd. What else? 2s aren't gonna work. 3, 1, they're both odd. 3, they're both odd. And 4s aren't gonna work. So I see 4 of them that are both odd. Did I do that right? Yeah. Okay, so the probability that they're both odd would be 4 out of 16. Or 1/4 if I reduce that. All right. So the probability that exactly one is even, I'll do that in green, one even. So that would be this one, that's one odd, one even, one odd, one even, one odd, one even, not that one odd, one even, odd, even, odd, even, odd, even, there. So all the green ones have exactly one odd and one even. So I'm going to count those. 8. So 8 out of 16, exactly half of them have both one odd and one even. Now, I don't even have to go count the other one, because how many will have both even now? 4, because 8 and 4 is 12, right? You have 16 possibilities, so there should be 4 of them that are exactly have both even. I'll go check it just to be sure. If they're both even, we'll do this guy, sure. If they're both even, let's see, I've got this guy, this guy, this guy, this guy, right? There's 4 of them. All right, so exactly what I expected. So the probability they're both even is 4 out of 16, or 1/4. All right. But what I want you to notice, those probabilities, 1/4, 1/4, 1/2, they all add to 1. They have to add to 1. Okay, because they're all the possible outcomes. You guys good? Thus far? Any questions? All right, another experiment. All right, so a pair of 4-sided dice are thrown and you observe whether the sum is 6, bigger than 6, or less than 6. All right, so X would be the sum of the dice. And the outcomes are either it equals 6, it's greater than 6, or it's less than 6, right? Those are the only possible outcomes. Okay, so we're going to go back to our dice table and count. I'm going to erase all my work up here. All right. How many of the sums equal 6? Go ahead and count them. Somebody tell me when you figure that out. How many of them equal 6? How many of the sums equal 6 exactly? 4? Huh?
That's what I count.
Did you count? Anybody count anything different? How many equal 6 exactly?
5.
9? Okay, let's do some counting. 1 and 1 is what? 2. Okay, so 1 and 2 is 3. So none of them in the first row. What about in the second
Yeah.
row? It's 2 and 4, right? That equals 6? Yes? Third row, which ones equal 6? They have to add to 6, not multiply. Which one in the third row adds to 6?
3 and 3.
3 and 3. All right, in the fourth row?
4 and 2.
4 and 2, all right, and that's it, right? Those are the only ones that add to 6. So you've got 3 out of 16 total, right? That added to 6. So probability that it equals 6 would be 3 out of 16. Okay? Now I'm going to go back and I'm going to count the number that are greater than 6. So I'll do that in blue. Greater than 6. How many sums are bigger than 6?
Also 3.
3, right? These 3 down here. This adds to 7 and this adds to 8, right? So those 3 are bigger than 6. So it'd be 3 out of 16. Now, I can go count how many are less than 6, but I already know, right? Because so far I've accounted for 6 out of 16, so how many are left? 10, right? So the probability that it's less than 6 should be 10 out of 16. We'll go count them just to make sure. Less than 6. We go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 rolls that are less than 6, all right? So probability the roll is less than 6, or the sum is less than 6, is 10 out of 16, which is 5/8, right? See how the sum in the bottom row, 3 16ths, 3 16ths, and 10 16ths, that adds to 1. That's 16 16ths, okay? The sum of those should always add to 1. All right? You guys okay online?
Yes, ma'am.
Any questions? You good? All right. Now, this next problem, they're going to do something with you guys called expected value, which is kind of like a gambling deal. It's a weighted average. It says Abby tosses a pair of 4-sided dice. So we're going to go back to our dice chart. If the product of the numbers is even, Gail pays Abby $2. If the product of the numbers is odd, Abby pays Gail $5. Let X be Gail's winnings. So this is X, is Gail's winnings. Okay, so what I'm going to do here, so if the product is even, Gail pays Abby $2, so Gail is out $2. So her expected winnings there are -2 because she lost some money, right? All right. And if the product of the numbers is odd, Abby pays Gail $5. So in that case, Gail is $5 richer, so her winnings are $5. Okay. Okay, let's get the probability of each. All right, the probability that the product is even, I think we already did this, didn't we? Yes, the probability that the product is even was 3/4, right? Go back to the first example. The probability it's odd is 1/4, it's the same problem. All right, who do you think's gonna come out on top here, Gail or Abby? That's the gambling question. And we're going to find out, okay? So you guys will be doing something called expected value. It's like a weighted average, and they write it like this. What you do is you take the probability of each event times its outcome. And you add them up. So I do 3/4 times -2. So there's a 75% chance she's going to lose $2, plus a 25% chance she's going to win $5. So whatever that comes out to be, that would be her expected winnings. That's what we call expected value. So I'm going to plug that in the calculator. So let's see, 0.75 -2 plus 1/4, I'll just say 0.25. All right, so the expected value is -0.25. So a negative expected value tells you on average, Gail is going to lose 25 cents. If she plays it for a long time, she's going to lose 25 cents. All right, so it's a losing game. Okay, when you guys get to expected value, if the expected value of the thing equals 0, that's what we call a fair game. Okay, so that means it's just as likely as you win as you lose, and so overall you're going to break even. All right, so when the expected value is 0, it's a fair game. If you go to Las Vegas, those games aren't going to be even. They're not going to have expected values of 0, not even probably -1/4. They're going to have some negative expected values because if you go to Las Vegas, the expectation is you're going to lose money, right? That's why, the casinos win out big. Okay, they can afford those big payouts because people lose money. Okay, and they know what the odds are. All right, so let's do this here. So it's another probability distribution. Each of 2 spinners is spun once. The sum of the 2 spinners is observed. So that's my experiment. So the first spinner, she's kind of drawn out a table for all the possibilities. The number is either going to be 1 or 2. That would be your first spinner. Your second spinner, the numbers are 1, 2, or 4. So that's these, all right? So this first branch is your first spin, and then this guy is your second spin. So what this is doing is laying out all the possible spins. So I can roll 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3. So I've laid them all out. How many possible outcomes to this? How many, if I note the sum, how many possible outcomes? All right, so what we're doing down here is we're taking the sum, right? Because we're counting the sum of the numbers. So she did 1 and 1, she did 1 and 1 is 2, 1 plus 2 is 3. See how she added the sums? All right. So what you're seeing on the bottom is all your possible sums, all right? So if you look at that, there are 6 possibilities of things that could have happened, right? Right. So for X, you're calling that the sum. So these are the sums right here. This is all I'm looking at, this bottom row. These are all the possible sums of all the spinners. All right. And she's laid them all out. The sums go from 0 to, well, sort of from 0 to 6. What's the probability that the sum is 0? 0, it can't happen, right? If you look at this dice, the smallest sum is 2, right? So that probability is 0. What's the probability the sum is 1? It's 0, right? Because there's no 1s in here, right? All right, so the probability that the sum is 2, how many 2s are there? 1, so it'd be 1 out of 6 possible outcomes, right? So it'd be 1 out of 6. The probability that the sum is 2 is 3. Is what?
2 out of 6.
2 out of 6, right? Which we can reduce to 1/3. The probability that the sum is 4.
1 out of 6.
1 out of 6. The sum is 5.
1 out of 6.
And the sum is 6.
1 out of 6.
All right. So you see that these all add to 1, right? That's all I can do. All right. So the probability of that bottom row, it better always equal 1. All right. So that's all we're doing with that one. Is that all we're doing? Yeah. Okay. Is that all right? Okay, so this is the probability distribution table. The 0 and the 1 aren't necessary. They shouldn't be in there really because they're not outcomes. All right. Now, we're going to apply this to gambling. Sam pays $3 to play a game. That's important. He spins each of the 2 spinners shown above. Whatever the product of the 2 numbers is, Sam wins that many dollars. Okay, product. Let X be his net winnings. Compare the probability, compute the probability distribution. All right, so let's talk about it. I'm gonna lay out her tables. All right, so I'm gonna get the products, right? It's a little different because I was doing the sums above, right? So let's do the products. So 1 times 1 is 1, right? 1 times 2 is 2, 1 times 4 is 4. So I'm just taking the products. 2 times 1 is 2, 2 times 2 is 4, 2 times 4 is 8, right? So those would be all the possible products. See that I just multiplied all the spinners together. Now, okay. Compute the probability distribution. So X would be the products. All right, so what are the possible products I have? I'm going to list them all here. 1, 2, 4, and 8. That's it, right? These are all my outcomes right here. 1, 2, 4, and 8. Is there 6 somewhere? Okay, there said products, so we're multiplying. All right, so let's talk about that. Whatever the product of the numbers is, Sam wins that many dollars. So we're not doing sums now, we're multiplying. You see, so there's no 6. Okay, because I'm multiplying. Is that all right? You have to be careful the wording of these things. All right, so probability of X. All right, what's the probability the product is 1? How many outcomes? How many outcomes total? 6. So the probability the product is 1 out of 6. What's the probability that it's 2?
1/3.
6. All right, the probability, or 1/3, reduce it. The probability that the product is 4 is 2 out of 6, which is 1/3. And the probability that the product is 8 is 1 out of 6, right? All right, now we're gonna do something that they didn't ask you to, but they're gonna ask you to in 1324 is to find the expected winnings. All right, that's what we call the expected value. Take the probability times the winnings. Now, one of the things you have to keep in mind with winnings, he's gonna lose $3 off of all the winnings because he's got to pay $3 to play the game, right? So if he wins $1, he hasn't really lost, right? What's he done? He hasn't really won. What's he done? He's lost 2. So here he's lost $2. So I'm going to put winnings up here. And if he wins $2, well, 2 minus 3, he's still losing money here, right? He's losing $1. And if I do 4 minus 3, well, oh, now we're winning money. I won $1. And 8 minus 3 is 5, right? So those would be his winnings. I have to take off what he paid, all right? All right, so now to find the expected value, you're going to do the probability times each of the winnings. So it's 1/6 times -2. I'll call this expected value. And I'm going to do plus 1/3 times -1, plus 1/3 times 1, plus 1/6 times 5, okay? I, as a gambler, would like to see a positive expected value. As a casino, I need to see a -1. All right, so let's see what that comes out to be. I believe it's going to be positive. Plug it in the calculator. Oops, sorry. No, well, let me do that there. All right, so it's 1/6 times -2. Move this over. Plus 1/3 times -1. Plus 1/3 times 1, well, they're going to cancel each other out. Plus 1/6 times 5. All right, so the expected value, ooh, wow, really? Did I do that right? Yeah, I did. Oh, no, I didn't. I have an error. Let's fix it. Let's type, we go to the second entry. I forgot to put a 1/6. I put times over here. I put 1 times 6. That's 1 divided by 6. There, I got 0.5. So on average, he plays this a lot, he's going to win 50 cents. So it's a game I play because I'm going to win something. All right. So the expected value is 1/2 is 0.5. He's going to win something. He's going to win 50 cents. So a positive expected value in gambling is a good thing for the gambler. It tells you you're going to win money. Negative expected value is what's typical. Most people will lose money. A 0 is what they call a fair game. All right, so we're going to do some card problems. You guys familiar with the deck of cards? Yes, no, okay, because some people aren't from different countries. So just to kind of quickly go over it. That was one thing that really shocked me. I don't know, many years ago when I took probability in college, we had a lot of people from other countries and they never played cards. So they didn't know how a deck of cards was arranged. So this is a standard deck of cards. These guys here are your aces. They're called aces. These are your numbered cards and the numbers up top. These are called face cards. And these are called aces. All right, you have 4 suits. These are called clubs, hearts, spades, and diamonds. So you have 13 cards in each suit. You have 52 cards in a deck of cards. All right. 4 aces, 12 face cards. All right. So we're going to hit some probability distribution tables. It says a card is drawn from a standard deck of 52 cards. You observe whether a numbered card, a face card, or an ace. All right. So X, I'm going to put X here as the type of card. And it's either going to be a numbered card, a face card, or an ace. I want the probability of each if I draw it at random. All right, so how many, how many numbered cards are in the deck? So we got to count them, right? So I go, okay, 1, 2, 3, 4, 5, 6, 7, 8. There's 9 times 4, there's 36 numbers. All right, number 2 for 10. So the probability I draw a numbered card is 36 out of 52. All right, how many face cards in the deck? You guys
12.
tell me. 12. So the probability I draw a face card is 12 out of 52. And how many aces?
4.
The probability I draw an ace is 4 out of 52. All right. Those probabilities, if I add them up, they're going to add to 1. They have to add to 1. I'm going to reduce the fractions. I'm just going to use a calculator to do that. 36 over 52. Oops. Oopsie, whoopsie. All right, 36. Just did this one over 52. I'm going to hit math frac. I get 9 over 13. 12 out of 52 is going to reduce to, all right, 12 out of 52. I'll just do math frac. It is 3 out of 13. And this is going to reduce to 1 out of 13, okay? So the numbers add to 1, 9 13ths and 3 13ths is 12 13ths, so I know it's 1 13. All right, so those are all my probabilities, okay? So there's my, my probability distribution table, okay? You guys okay? Yeah? Okay. All right, let's look at another one. So now we're going to do a winning problem. Okay, a card is drawn from a deck of 52 cards. If it is a red card, Sam wins $4. I'm going to put a 4 up here. He won $4 and he gets a red card. If it is a black face card, so black face card, he must pay $3. So he's going to be down 3. If it's neither of those, he wins $1. Okay, so let X be his winnings. All right, and I need the probability of each. So the probability that he draws a red card out of a deck, how many red cards in a deck? So it's 26 out of 52, or a half. Black face cards, let's see, let's go count. How many black face cards? Huh? 6, right? 1, 2, 3, 4, 5, 6, right? So it'd be 6 out of 52. I'll just reduce it on the calculator. Well, it's going to be 3 out of, well, I might as well do it. 26. Sure, so it's 3 out of 26. Now, you don't have to go count the neithers because you've got 26 and 6, so you've got 32 out of 52 taken over, right? So how many are left that I haven't accounted for? 20, right? Because 20 and 32 is 52. So there's 20 of the neithers, so it's 20 out of 52. If I reduce that, I'll just do it in a calculator. I think 4 goes into both of them. All right, I get 5 over 13. All right, so there's my probability. Now let's talk about his winnings. So his expected winnings, you take the probability times the winnings. So the expected value of X. So I've got 1/2. Half the time he's going to win $4. 3/26 the time he's going to lose $3. I think he's going to get a lot of money on this one. All right, and then 5/13 of the time he's going to win $1. I think this is one I would want to play. All right, so let's plug it in the calculator and see what his expected winnings are. All right, so 1/2 times 4 minus 3 times 3/26. Sorry, this keeps popping up like that. Plus 5 over 13? All right, I get 204, about $2.04. That's pretty good winnings there. So if I play it over a while, I'm going to win about $2. All right, that's pretty good odds stacked in my favor. All right, so that's a game I'd want to play. All right, you guys good? Okay. And this is important. Ray pays $3, so he's down 3 no matter what. He draws 1 card from a standard deck of 52 cards. If it is a red face card, he pays an additional $2. So how much is he out? He pays an additional 2, he paid 3, so he's out $5, right? So his net winnings are -5. If it is a black numbered card, he wins 5. But be careful with that. He didn't win 5 because he had to pay $3, right? So he's really only winning $2. And if the card doesn't fit either of those categories, he wins $1, but he's still out money because he paid 3, right? So he's actually down 2, right? So anything else, he's down $2, all right? Because he paid 3 and he lost it, he got 1 back. All right, so let's come up with the probability. So the X, this is winnings. All right, the probability of each. So the probability that he draws a red face card. How many red face cards in a deck? Let's go up to the deck. How many red face cards? 6, right? King, queen, jack of hearts, king, queen, jack of diamonds. So the probability he draws a red face is 6 out of 52. The probability that he draws a black number. How many black numbers are there? How many black numbers?
16.
16, is that right? I think there's 18, right? Because there's 9 of these. Right, don't count the aces, right? So there's 9, and 9 is 18. Yeah, 18. All right, so 18 out of 52. And to figure out what's left, all you have to do is figure out how many cards you haven't accounted for. So 18 and 6 is 24. So how many cards haven't I accounted for? So do 52 minus 18 minus 6. What do you get? 28, so it's 28 out of 52. All right, and I can reduce the fractions to make the math teachers happy. Let's see, 6 out of 52. Let's do math frac. I do 3 out of 26, 18 out of 52. All right. 9 over 26. And this is going to be 14 out of 26. All right. So there's my probability table. All right. So let's do the expected value just for the thing. I think he's going to lose money on this one. You think? Like it's $2. I don't know. We'll see. All right. So the expected value, take the probability times the winnings. I think he's going to lose money. Let's see. So 3 out of 26 times -5. Plus 9 over 26 times 2. Plus, I didn't reduce that all the way, did I? 7 over 13, which is bugging me. All right, 7 over 13. Times something, where'd it go? Times -2. All right, so his expected winnings are -96 cents. All right, so he's gonna lose money on that one. Okay, if you guys ever gamble, I mean, all the games in Las Vegas have negative expected values because you're gonna lose, right? I mean, that they offer these big pots because yes, somebody's gonna win, somebody's gonna beat the odds, but on average, they're gonna beat the odds. The casinos get money, right? So you're losing 96 cents, but they're gaining a buck. And so that's how they do that. And they definitely they work those odds out so that it comes to their favor. Okay, so I'm done my material for today. Is there any questions you guys have over anything you're doing in 1324? Anything I need to go over? What do you guys do? Are you doing two-way tables? What are you doing? Venn diagrams?
Just got done with the diagram.
Okay, you just got done with Venn diagrams?
Well, we have a test still, but we're just took the quiz over that.
Took a quiz over Venn diagrams. How'd that go?
There was one question that I had to ask on.
Pardon?
There was one question that I had to ask on.
Are you talking about the one with trig algebra, the like P's one, there's like the tall P's and the
Yes.
small P's? Yeah, I had trouble with that one too.
We
I had
did-
to.
We didn't
Yeah.
go over that.
If you guys ever, like, if you want to bring a problem, you can go over it in class, whatever you want to do, okay? Because like when I have extra time like this, I don't mind going
Can
over
you
stuff.
show us how you like do the trig algebra when you're looking at?
Yeah, I need a problem.
I
Do
had
I think it's on the,
it.
yeah, I think it's on the quiz.
you have it?
I think we can look at. the
Okay,
quiz.
we're gonna pull up your quiz.
Professor, are we good to go if we don't need it?
Yeah, you're good to go. If you're feeling good, you're good to go. But if you want to stay and look at the Venn diagram, I'm gonna go over that with them. We're looking for it right now. Yeah, what I do with Venn diagrams is I fill in as much information as I can first. I usually start at the bottom row and then work backwards. And then the ones I don't have, I put like X, Y, and Z in. So it reduces the amount of equations you have when you have that problem. But they're looking for the problem right now. We're trying to find it. Did you guys find it or no? Still looking?
Yeah, I'm going, it's loading.
I'm not on Blend's.
Huh?
I'm not on Blend's Wi-Fi. So
Yeah, I
don't
have to use a hotspot.
Yeah, me too. I don't know.
Oh, you can't get on the hotspot?
I can't get on the Wi-Fi.
And if you guys have it at home, you can share your screens. We can do it that way. If you have it, let me know and we can share the screen. I have to set it to let you do that, but can't get on.
Oh, I'm on right now. I don't know if we're gonna be able to look at it.
Okay, all right. You can bring it next time and I'll be happy to go over it with you. See, I don't have anything with X, Y, and Z on it, I don't think.
That was the 7.3 and 4 quiz.
Yeah, I'm seeing what I can find. I don't have access to her stuff, so I have to make it up. Three circles with unknowns. Let's see if I can find a problem. I'm trying to find one that, I know what you're talking about, one that's difficult with,
Because it leaves you with 3 blanks. It leaves you without,
just gotta, okay, I think, okay, this one would work. 64 taken math, okay. I think this one will work. If it doesn't, I'm sorry, but we'll show you kind of the process. I'm gonna share, no, I can't share the screen. Yes, I can. How do I get to here? I'm gonna share screen too. Sorry, I gotta switch gears here a little bit, so it's gonna take me a second. Where's my mouse? There it is. So let's try. All right, can you guys online see it? Okay. You guys, I'm gonna put my mask on. You wanna come up and look at my screen? There's only 2 of you. I can't figure out how to do it. Oh, no, you can see my screen. Never mind, you can see that, right? You don't have to. Okay, you see that. All right, it says in a survey of university students, 64. It's not, okay, let me get my pen so I can write. Let me do annotate. All right, 64 taken a mathematics course, 94 taken chemistry course, 58 taken physics course, 28 taken math, physics, 20, the whole thing, right? So we're comparing math, physics, and chemistry. So I'm gonna have 3 circles. Math, physics, and chemistry, okay? All right, so what I like to do is start at the bottom, the last sentence, and work my way backwards, all right? 14 had taken all three. I'm going to start there because that's the easiest. All three is the overlap of all three circles, so that's right there, right? All right? Okay. I'll answer the question at the end. All right. So 22 had taken chemistry and physics. So chemistry and physics would be this circle right here. So it's going to add to 22. So I have to do 22 minus 14, right? Which would be 8. Yeah, it's 8. Okay, so this is 8 right here. All right. So that takes care of that. 26 had taken math and chemistry. So math and chemistry would be these guys. So I'm going to do 26 minus 14, 12. This needs to go here. 28 had taken mathematics and physics. So this needs to be 14 to add to 28 there. All right, I'm hoping, it looks like I'm going to get to fill this all the way in. See, 58 had taken a physics course. So I'm going to do 58 minus the numbers 14, 14, and 8, right? So with a calculator, I'm going to do 58 minus these guys. Tell me what that number is. What do you get? Yeah, 22. All right, that goes there. All right, 94 and taking chemistry. So do 94 minus 12 minus 14 minus 8, right? 60. Okay, and 64 taken mathematics. So I do 64 minus 14 minus 14 minus 12, right? So I think I'm going to get 24. Is that what it works out to? All right. A little bit of a problem with this problem is they're assuming that there's some that may have taken none, and we're assuming that there's 0 that took none because they didn't say it, right? So that wasn't one that I needed the X, Y, and Z thing in because I could pretty well fill it out. But I do always start with the middle, a last sentence, and work my way backwards because that's easier, okay? And then I can answer the questions like, what was the question? How many had taken only one course? So I would take this guy, and that guy, right, and add them together. And I get 106. All right. So, no, that's not right. Yeah, that's right, 106. So, you really want to work these backwards, but when you don't know something, you fill in an X, Y, or Z. I was hoping that would do it, and it didn't.
You're talking about like if you
Huh?
didn't, you're talking about if you didn't.
If
so
I didn't
it
know a
didn't-
few of them because they were so complicated, right, I just fill it in. Whatever ones I didn't have filled in, then here, let me do this.
So like on the one we're talking about, it didn't give you.
It doesn't give you one, right? But it
It's-
gives you enough information, like, what do I want to say? They don't have an example. Oh, here we go. There it is. Look at that. Okay. So here's one where, they filled in all this information. They didn't give you this one, but I don't do it the way that they just talked about it. So, do you have time for me to do this one? I have time? Yeah, I have time. Let me do this one real quick because this is going to have a variable in it. All right. In a town. All right. We've got 85% of the people speak Tamil, 40% speak English, and 20% speak Hindi. So let's do this. Tamil, English, Hindi. Also, 32, they have the anons, right? But you see they don't have the one with all three, right? So what I'm going to do is I don't have the middle, so I'm going to call that X. Okay? All right, so now I'm going to work backwards. All right, so let's see. 10% speak English and Hindi. I'm just going to do like 10 is 10%, all right? So English and Hindi have to add to 10. So if this is X, this is 10 minus X, right? Add to 10. All right. 13% speak Tamil and Hindi. So 13, this would have to be 13 minus X. I don't know what X is, right? All right. 32 speak Tamil and English. So this would be 32 minus X. All And, okay, 20% speak, now I'm gonna start setting up some equations. So 20% speak Hindi, right? So I don't know, this has to all add to 20%, right? So I'll call this Y. So if I add these all together, it's gonna be 20, right? So 13 minus X plus 32 minus X, right? Plus Y has to equal 20. See how I set that equation up from that? All right. 40% speak English, so I'll call this Z. So if I add those up, they have to add the 40. So all the Englishes would be 10 minus X plus 32 minus X plus Z equals how many? 40? Right? And last one, 85% of people speak Tamil. So I'll call this W. So if I add them up, 10 minus X plus 13 minus X plus W has to equal 85. All right, so I've got these three equations, right? So hopefully something's gonna come out of them, all right? So let's simplify this thing. These cancel. 13 plus 32, I need to, let's see, so 45, is that right? Minus X plus Y equals 20. I'm gonna move the 45 over, so negative X plus Y, 20 minus 45 is gonna work out to be negative 25. Hold on to that one. Okay, and then this one, those cancel, so I get 42 minus X plus Z equals 40. So minus X plus Z equals negative 2. I just move this over. And this one, those cancel. So this one I get 26 minus X plus W equals 85, right? Is that all right? So minus X plus W, what's 85 minus 26? 9, is it 59? Okay, hopefully I did that right. Yeah, okay. Now, the other thing you have to remember, if you add up all the circles, it's 100%. Or is there somebody that doesn't speak all three? Are we assuming at least one person speaks all three? That they speak at least one? You see the problem with this particular website?
I believe that would be what X is, so we don't know what that is. The one that speaks all three is where X is at, right?
That's what I'm trying to find, but am I assuming there's no one out here? Yeah, they have to speak some kind of language, right? So there's nobody on the outside, all right? So if I add up everything in here, it should be 100%. If I add up everything, I need that equation too. All right, so if I add up all the stuff in the circles, it should be 100%. So if I add up, let me write this big equation. This was harder than I expected, but it's all right. All right, so how come it won't let me annotate? We're assuming that they speak at least one language. They should say that in the problem, but we'll forgive them. All right, so W plus, I'm going to add up everything. That has to equal 100, right? That covers the whole town. Okay, so we'll simplify it. So W minus X plus Z plus Y. And let's see, we've got 10, that's 23, 33, 43, 53, 55. It's plus 55 equals 100. So W minus X plus Y plus Z equals, what's left, 45? Okay, so this is where life gets fun, all right? I play, all right? So I know that W minus X, see, if I look at this, I know that's 59, and I've got a problem because I have 59 plus Z plus Y equals 45, and the problem is that's going to give me negative numbers, so I have an addition error somewhere. All right, so I've got a problem. All right, So I didn't do it as like I wanted to, but my point to you is you fill in what you can, right? And then you start playing with the equations. Like what I'm just looking at it, I don't have x plus y. Well, actually, I could solve this for negative x, just to kind of show you negative x would be -2 minus z. And I could put that in up there and I get something for negative z plus y. I need z plus y. I've got some kind of sign error in here somewhere, so it's messing it up. But I want you to understand that that's kind of how I play with it. Once you get the equations, you just plug them in, all right? If you bring your test problem next time, we can go through it.
I had it in my other booklet.
Okay. All right, well, we're done.
Roommates are engineering majors and they're